The false positive paradox shows that things are not always as it seems. It is a statistical result related to medical testing that shows false positive tests are more probable than true positive tests when the overall population has a low incidence of the condition. So, if you go to the doctor to have a test for a disease and the test comes back as positive, do you actually have to have the disease, or is there a chance you don't have the disease? To figure out the actual probability of having the disease, you need three important figures. The specificity of the test, which tells you what percentage of the time the test correctly tells you if you don't have the disease. The sensitivity of the test, which tells you what percentage of the time the test correctly tells you if you do have the disease. And lastly, you need the figure of how common the disease actually is. For example, imagine only 2% of the population has a disease. The specificity of the test is 97%, and the sensitivity is 96%. This test seems to be incredibly reliable, right? We'll see if it actually is. First, we need to look at the population as a whole. There'll be people with the disease and people without. 98% of people don't have the disease, and 2% do. When these people take the test, the two possible results are positive and negative. For people with the disease, they should test positive, and the sensitivity figure shows how often it correctly identifies someone with a disease, which is 96% of the time. That means the other 4% of people get a negative test result, even though they actually do have the disease. Because that conclusion is incorrect, it is termed as a false negative. Next, for people without the disease, the test should show up as negative, which the specificity figure tells us only happens 97% of the time. That means the other 3% of the time, it incorrectly shows up as positive, even though they actually don't have the disease. This conclusion is also incorrect and termed as a false positive.
Now let's use actual figures and suppose we test 10,000 people for the disease. 98% of the people, or 9,800 people, would not have the disease. The remaining 2%, or 200 people, would have the disease. For people with the disease, 96% of them would correctly come with a positive result in the test. So 192 people would get a correct result. The remaining 4%, or 8 people, would get an incorrect false negative result. In people without the disease, 97% of people would correctly get a negative result, so 9,506 people would get the correct result. The remaining 3%, or 294 people, would get an incorrect false positive result. Back to the original question. If you have a positive test result, how likely is it that you actually have the disease? Well, in this scenario, 486 people in total have been tested positive. Of those 486, only 192 of them actually have the disease. So our probability is 192 over 486, or in other words, only 39%. So you've taken the test and gotten a positive, but the probability of actually having that disease in this situation is only 39%. So the test may look accurate when you first look at the figures of how often it is correct. In reality, the high figures are not always correct, and even if you get a positive test result, you are still not that likely of actually having the disease because so many people don't have the disease. So, however small there is a chance of making a mistake, there will be a lot of people involved in the mistaken figure.
So, the reality of it is a lot different from what it actually seems to be. Thanks for watching.
I'm Lauren.
I'm Swetha.
And I'm Patience.
And we're the Three Mathemateers.